Okay, so let's start. So today I will be explaining about naming ionic and covalent compounds. So naming ionic compounds are compounds made of a metal and a non-metal. Binary ionic compounds. It consists of two elements. The rule is name of the first element and root word of the second element plus IDE. Examples: NaCl. Name of the first element, which is Na, is sodium, and root word of the second element plus IDE. So root word of the second element Cl is chlor plus IDE is chloride. So NaCl, it's sodium chloride. Next, Mg3p2. Name of the first element, Mg, which is magnesium, and root word of the second element plus IDE, which is phosphide. So Mg3p2, it is magnesium phosphide. Okay, so just now the rule is name of the first element and root word of the second element plus IDE. So here are some examples. Lithium oxide. The answer is Li2O. But how do we got it? So first, lithium. Lithium is Li. Li is positive 1. And oxide is oxygen here. So negative 2. So we cross multiply. So we got 2 and 1. So we got Li2O1. But we don't need to write the 1 because it doesn't matter. So we just write Li2O. Yes, that's how we got it. So next, magnesium phosphide. Magnesium is Mg. So here, Mg. Mg is positive 2, so we write positive 2. Phosphide, it's P, so it's here. P is negative 3. So we cross multiply them. Got 3 and I get 2. So that is Mg3p2. So it's the same. So next, calcium sulfide. Calcium is Ca. So it is positive 2. So Ca positive 2. Sulfide, so it is S. So it's negative 2. Negative 2. And we cross multiply it. So we got Ca2S2. We can simplify it by dividing by 2 both of them. So we got CaS. The same. So next, barium. Barium is Ba. carbide, which is carbon, it is here, -4. So we cross multiply it, we got 4 and we got 2. So Ba4 C2. We simplify it by dividing by 2. So we got Ba2C. So that's how we got it. Okay. So next we have ternary ionic compounds. So we have cations and anions. Cations are positively charged. So examples, we have NH4 plus, which is ammonium, and NH3, which is ammonia. For anions, it is negatively charged. So we have ClO3 minus, BrO3 minus, IO3 minus, NO3 minus, MnO3 minus, CO3 raised to the power of -2, SO4 raised to the power of -2, CrO4 raised to the power of -2, PO4 raised to the power of -3. So here are some guidelines. So first, if in their original number of oxygen atoms, the rule is root word of the first element plus ATE. Examples, ClO3 minus. So we can look here. So ClO3 minus, it is in their original number. So the rule is root word of the first element Cl, which is chlor, plus ATE. So ClO3 minus, it is chlorate. Number 2, if with less one oxygen atom, the rule is root word of the first element plus ITE. Examples, ClO2 minus. The original number of oxygen atom, it is 3. So now we have 2. So it is less one oxygen atom. So we use the rule root word of the first element Cl, which is chlor, plus ITE. So ClO2 minus, it is chloride. So 3. If with less 2 oxygen atoms, the rule is hypo plus root word of the first element plus ITE. Examples, ClO min. So the original number of oxygen atoms is 3. So here it is just 1, but we don't need to write it. So it is less 2 oxygen atoms. So we use the rule hypo plus root word of the first element, which is chlor, plus ITE. So hypochlorite. So fourth, if with one more oxygen atom, we use the rule per plus root word of the first element plus ATE. Examples, ClO4 minus. So the original number of oxygen is 3. So now we have 4. So it is more 1 oxygen atom. So we use the rule per plus root word of the first element Cl, which is chlor, plus 8. So perchlorate. That's how we got it. here are some examples of ternary ionic compounds. So first, we have MgBrO3 So Mg, we know that it is magnesium, and BrO3, check here, it is in their original number of atoms. So just now the rule is root word of the first element plus ATE. So it becomes bromate. So magnesium bromate. Next, Al2SO2 We know that Al is aluminium, and SO2 check here. It is less 2 oxygen atoms. So we use the rule hypo plus root word of the first element plus ITE, which is hyposulfite. So aluminium hyposulfite. So third, Ca. Ca is calcium, and MnO4 it is more 1 oxygen atom than the original number of oxygen atom. So we see the guidelines. We use the rule per plus root word of the first element plus ATE. So it becomes permanganate. So calcium permanganate. So fourth, NaIO2. Na, we know that it is sodium, and IO2, you can see it is less 1 oxygen atom than the original number. So we use the rule root word of the first element plus ITE. So it becomes iodide. So sodium iodide. Okay, naming covalent compounds. We have some Greek prefixes for number of atoms, such as mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, deca for 10, undeca for 11, dodeca for 12, trideca for 13, and icos for 20. Okay, here are some guidelines. So first, use appropriate Greek prefix to represent the number of atoms per element in the chemical formula. Second, avoid using mono for the first element with single atom. Third, for oxygen, omit letters O or A for the equivalent Greek prefix to be used. And fourth, for the second element, take the root word and add the suffix IDE. So examples, N2Br13. So 2, it is di. So N, it is nitrogen. So dinitrogen. 13, we see it is trideca. So trideca, Br, bro, plus IDE, so bromide. So dinitrogen trideca bromide. Number 2, PCl3. P, it is just 1, so phosphorus. Cl3, 3 we use tri, and root word of Cl is chlor plus IDE, so chloride. So phosphorus trichloride. So next, S2Cl2. 2 we use di, so disulfur dichloride. The root word of Cl plus IDE. So next, N8F5. 8 we use octa, N we use nitrogen. N is nitrogen, so octa nitrogen. 5 we use penta, and F is fluor plus IDE fluoride. So octanitrogen pentafluoride. Number 5, CCl4. C, it is carbon. 4, we use tetra. Cl, it is chlor plus IDE, so chloride. So carbon tetrachloride. So C, the last one is C9CL4. C9, we use nona. C is carbon, so nona carbon. 4, we use tetra. Cl is chlor plus IDE, chloride. So nona carbon tetrachloride. Okay, so acids. It is a covalent compound which produces hydrogen ion H+ when dissolved in water. It has a pH level lower than 7. Acids. To identify acids using indicators such as litmus paper. If it is BRA, so it's blue, red, so it is acid. If it's RBB, which is red, blue, it is a base. For naming binary acid, we have a gaseous form and diluted form. So the rule for gaseous form is hydrogen plus root word of the second element plus IDE. So examples, HCl. Hydrogen plus root word of the second element, which is Cl plus IDE. Hydrogen, the root word of Cl is chlor plus IDE, so chloride. So hydrogen chloride. For H2S, it is hydrogen, root word of the second element plus IDE, which becomes sulfide. So hydrogen sulfide. For diluted form, the rule is hydro plus root word of the second element plus ake plus acid. Examples, HCl. AQ is aqueous. So we use the rule hydro, root word of the second element Cl, which is chlor plus IC plus acid, which becomes hydrochloric acid. So number 2, H2S. We use hydro plus root word of the second element plus ake plus acid, so it becomes hydrosulfuric acid. Next. Naming ternary acid or oxyacid. Here are some of the examples. ClO3 minus, BrO3 minus, NO3 minus, IO3 minus, MnO3 minus, CO3 raised to the power of negative 2, SO4 raised to the power of negative 2, CrO4 raised to the power of negative 2, and PO4 raised to the power of negative 3. So last, we have some rules. So rule number 1, if an original number of oxygen atom, the rule is root word of the second element plus ake plus acid. So example, HClO3. So we use the root word of the second element, which is Cl plus ake plus acid. The root word of Cl, it is chlor plus ake plus acid. It becomes chloric acid. So rule number 2, if with less one oxygen atom, we use the rule root word of the second element plus O's plus acid. The original number of oxygen atom is 3. So now we have 2. So it is less one oxygen atom. So we use the rule root word of the second element Cl, which is chlor plus O's plus acid, which becomes chlorose acid. So rule number 3, if with less 2 oxygen atoms, we use the rule hypo plus root word of the second element plus O's plus acid. So examples, HClO. The ordinal number of oxygen is 3, so now it becomes 1, but we don't need to write it. So it is less than 2 oxygen atoms. So we use the rule hypo plus root word of the second element Cl, chlor, plus O plus acid. So it becomes hypochlorous acid. So for the last rule, if with 1 more oxygen atom, we use the rule per plus root word of the second element plus 8 plus acid. So examples, HClO4. The original number of oxygen number is 3. So now we have 4. So it is 1 more oxygen atom. So we use per plus root word of the second element chlor plus 8 plus acid. So it becomes perchloric acid.